Imagine this. You are trying to solve a tricky triangle problem and you do not have to use a calculator. That is the magic of special angles. 0, 30, 45, 60, and 90 degrees. They make complex problems simpler. In this video, I will teach you the easiest way to remember these angles and show you how they apply in real life. So, stay tuned. There are two ways to help you remember the special angles. One is by using the wheel or the Venn diagram, and the other is by using two triangles. In this video, we are only focusing on understanding the concept. That is why we will only touch on the wheel method and not the triangles. Also, I've made a video called 7 Tips to Stop Failing Maths. Be sure to check it out after this one and let me know which tip resonates with you the most. Now, when you have the wheel, right? The first thing that you need to do is to know how to draw the wheel. It's very easy. This is how we go about it. The first angle that we have is 30 degrees. These are special angles, right? The other one will be 45 degrees, 60 degrees, and the last one will be 90 degrees. Okay? Now, when you have a circle, right? You have the center and the outer part of the circle. So the outer part of the circle is called the circumference, right? So a line from the center to the circumference is called the radius, right? So the radius value for all the radius on this circle will be equals to 2. So that's what I'm going to do. Radius equals to 2. Alright, now this is the coordinate, right? So a coordinate is made up of two parts, the x value and the y value. What is the first coordinate for our wheel? So the first coordinate will be square root of 4, and the second part of the coordinate will be square root of 0. Okay, so very important to understand. This is the x, right? And this is the y. Okay, now why do I have x in red? That is because the value inside the square root for the x part as you go along will decrease, right? And the value inside the square root for the y part will increase, right? So this is how we go about it. The next coordinate, you will have square root of 3, square root of 2, square root of 1, square root of 0. All right, so it is decreasing. So 4, 3, 2, 1, and 0. Right, now the second part of the coordinates, right? So the second part of the coordinates, what we have 0 here. So it's the y part which is increasing. So we started from 0, we are going to increase just like that. So what do we have? Square root of 1, square root of 2, square root of 3, and square root of 4. Okay, the last part, right, is to simplify. We need to simplify. Now, what is the square root of 4? The square root of 4 is 2, right? And the square root of 0 is 0, right? Now, the second part, what is the square root of 3? Square root of 3 is square root of 3, and then square root of 1 is 1. Okay, I'm going to go ahead and say square root of 3 is 3, square root of 1 is 1. Square root of 2 doesn't change, and then this one as well doesn't change. And then square root of 1, what we have 1. And then square root of 3 doesn't change, stays square root of 3. Square root of 0 is 0, and then square root of 4, we have 2. Now that you know how to draw the circle, I want us to understand what all these things means, right? So to help us understand, I'm going to explain it in a very simple way that you will understand, right? Now, let's say you have a diagram like that. You have the arm, and then the coordinates, you have x and y, okay? And then the angle theta, what do you have? You also know that this is r, all right? Now, the question is, how do you transform this diagram in a form of a triangle? Okay, it's very easy. Now, let's say you have the same Cartesian plane, right? The same arm, okay? So the same arm will be like that. I'll have r here, okay? And then going forward, so this will be in a form of a triangle. So that is 90 degrees. All right. Now, what does this x mean? Or where does it belong? Right. So this x is the value of x here, right? On the x-axis. So what I'm going to do is I'm going to go ahead and put that x here. All right. Now, what does this y mean? This y means the value of y on the y-axis, okay? So I'm going to put that y here. So we're going to take an example from the wheel and explain the very same concept that we explained on the previous slide, right? Now, very easy. So this is a Cartesian plane. You have the wheel, right? So we're going to start with special angle 30. So that is 30 degrees. What else do we know? We know that this is r, right? R, which is equals to 2, okay? Now, so that is r, which is equals to 2, and then the angle is 30 degrees. So we are taking that arm right there, right? So that arm, the coordinates that I'm going to put here, right? I'm not going to use this one. I'm going to use the simplified coordinates, right? Which are square root of 3 and 1. All right. So I'm going to go ahead and do that. Square root of 3 and 1. Okay. Now, how do we transform this diagram, right? Just like we did on the previous slide. Very easy. Take this. You have the arm. The arm is r, which is equals to 2. Okay? And then the angle that you have is 30 degrees. Okay? Now, look at this. This is the x and this is the y, right? Where do you put, let me put it like this. So 90 degrees. Where do you put the value of x? The value of x will be here, and then the value of y be here, right? So the value of x will be square root of 3, and then the value of y will be 1. Quick moment before we continue. Over 82.4% of people watching my videos haven't subscribed yet. If you're enjoying this and it's helping you, please hit that like button and subscribe. It's free and it helps the channel to grow and reach more students who need this kind of help. And if you have already subscribed, thank you. You are a real one. Let's keep learning and growing together. Let's continue. So this will be our x and this will be our y, right? So this is the opposite and this is the adjacent. All right. Now, what do we know? We want to write the special angles, right? And combine them with the trig ratios. So I'll start with sine 30. degrees, right? Now, what is sine 30 degrees? Sine 30 degrees is opposite over hypotenuse, right? So this is the same as hypotenuse, okay? Now, opposite, when you look at opposite is y, the value of y, over the value of r, which is hypotenuse, okay? So the value of r. All right, now, what do you have right here? You have the value of y as 1, right? So the value of y is 1 and the value of r is 2. What does it mean? So this means that sine 30 is equals to 1 over 2. All right? Now, let's tackle the second part where we have cos 30. Okay? Cos 30 is adjacent over hypotenuse. Okay? So adjacent is x. So this is adjacent, which is x. Hypotenuse is r. All right? So it's x over r. What is the value of x? The value of x is square root of 3. So I'm going to have square root of 3 over 2 because the value of r is 2. Okay. Now, what does it mean? It means that cos 30 is the square root of 3 over 2. The last one will be tan. All right. So tan 30 degrees. So tan 30 is opposite over adjacent. Okay. So opposite in this case is y over x. All right. So what do we have? We know that the value of y is 1. So I'm going to have 1 here, and the value of x is square root of 3. Right? That means tan 30 is equals to 1 over square root of 3. You can take this arm, right, and angle 45. Put angle 45 here, and then the coordinates, put square root of 2 and square root of 2 here, right? Transform it to this, and you can find the angles for sine 45, cos 45, tan 45, and then do the same for the rest of the angles. Question number 1. Example number 1 says in the rectangle ABCD. So it's ABCD. So this is a rectangle, right? We are given that AB, which is this side, AB is 4 centimeters. So this is a rectangle. That means CD is also 4 centimeters because this is a rectangle. This side is equals to that side, and this side is equals to that other side. Okay. Now, moving forward, we know that ABE, angle ABE is 45. So ABE is 45 degrees, and therefore angle BEC is 75 degrees. Right. Now, without using a calculator, what do we need to determine? We need to determine AEB. So this is angle AEB. So which angle is that? AEB. That means it's this angle. Okay. So first things first, you need to understand that the sum of angles in a triangle, okay, they are equals to 180 degrees. Or you can say that they are supplementary. Okay, so when you add 90 degrees plus 45 and you add angle AEB, that angle over there, they should give you 180 degrees. Let's do that. So angle 90 degrees plus 45 degrees plus angle AEB, which is 180 degrees. Right. Now I'm going to say AEB is equals to 180 degrees minus 90 minus 45. Okay, now the answer will be 45 degrees. All right, so that means that angle right there is equals to 45 degrees. Now, moving on to the second part of the question, we need to determine angle CED. CED, we need that angle, right? So, yes, one thing that you need to note, that the sum of angles, right, on a straight line, let's say straight line, right, they are equals to 180 degrees, all right? Or you can still say that they are supplementary. Okay, let's move on. So what do we have? We have on that straight line, we have 45, 75, and angle CED, right? So that angle. All right, so when we add those angles, they must give us 180, okay? So what I'm going to do is, I'll write angle 45 plus 75 plus angle CED. Okay, so if you don't put that cap here, that means this is not an angle. All right, so what makes it an angle is that cap. Okay, right, so this is 180 degrees. Right, so CED is equals to 180 degrees minus 45 degrees minus 75 degrees. Okay, now what is the answer? The answer is 60 degrees. That means this angle right here is 60 degrees. The second part of the question B, determine the length of AE, this side AE. All right, now AE, if I take this angle as my angle of interest, AE will be opposite and this will be adjacent. AB will be adjacent. All right, so I'm going to use tan because I know that side and I am interested on that side. So opposite and adjacent, that is tan, right? That is how you choose your ratio. So tan 45, which is equals to AE, which is your opposite, over AB. This is your opposite and this is your adjacent. We know that AE is what we are looking for and AB is equals to 4. Okay, so this side you still have tan 45. Now I want to cancel 4. What do I do? I multiply both sides by 4. 4 will cancel 4 and I'll be left with AE on one side, and then on the other side I'll be left with 4 times tan 45. Okay, now tan 45, right, is equals to 1. So I'm going to put 1 there. So my answer will be 4 centimeters. Don't forget to put the unit right there. Okay, so that means AE is 4 centimeters. 4 centimeters. All right, now moving on to the second part of the question. What do we have? We have AED. We need to calculate this side, ED. But what do we know from the question? We know that this is a rectangle and we know the value of AB, right? So we know the value of A, which is 4 centimeters. All right, now in a rectangle like this, right, this side AB is equals to CD. So that means CD is also equals to 4. Okay, now we know this is also 4 centimeters. All right, now what do I know? I know this side and I have this angle and I'm looking for this one. So I'll actually use tan again because it's opposite and adjacent. So I'm going to use tan, which is tan of 60, right, which is opposite CD over ED. Okay, so this will be opposite, this will be adjacent. Tan 60 is square root of 3, and then CD, we know CD is 4, right? So CD is 4 and ED we don't know. Now if you multiply both sides by ED, this side will have ED, and this side will have 4 over root 3. Alright, so 4 over root 3 will be my answer here for ED. 4 over root 3. So you can actually simplify it to be 2,31 centimeters. Even this side you can say 2,31 centimeters. The last part of the question is to determine the area of a rectangle, right? Now, the area of a rectangle is length times breadth, right? Now, what is the length on this rectangle, right? So it's AB. We know AB to be the length, and that the breadth is AD, right? So this is AD, or you can say BC. So I'm saying AD because I have the values here, right? And then AB, I have the value here. So even this one, we know it from the previous slide, that is equal to 4 centimeter, right? So I can either say CD multiply by AD, right? But what else do we know? We know that AD, right? AD is AE plus ED, right? So what I know again is that, so this AB multiply. So AD is AE plus ED, right? So this is what I mean. AD is AE plus ED, right? Now I'm going to substitute the actual values. So this will be 4, and then what is the value of AE is 4. That will be 4 plus what is the value of ED? ED is 2,31. So 2,31. Now punch this on your calculator. What do you get? I get 25,24 centimeters cubed, right? Because this is an area. Suppose you are looking straight down towards the base of a cliff and estimate the angle of depression to be around 60 degrees. If you can also estimate the horizontal distance between where you are standing to the next cliff, you can use the tangent ratio to estimate the height of the cliff. That's it for trigonometric special angles. I hope this made them easier to remember. Like, subscribe, and I'll see you in the next one.